Hello and welcome to this question. This question looks at the speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. The results are given in the table below with the time in seconds and speed in meters per second. Using all of this information, estimate the length of the runway used by the jet to take off. So for this question, so it's a velocity and time. So it's using a bit of mechanics here because if it's looking for distance, we know that for a VT graph, it's the area under the curve. So in essence, what we should do is do a mini plot of this. So if we do a mini plot, we start off with our first value. So at time equals 0, speed is 2, and then we have the next one, which is 5 and 5, and the next one, which is 10 and 10. Then the next one, so again we're going up 15, 20, 25. So at 15 we have 18, and then 28 at 20, and then 42. Well, that's much higher. So 42 with this one. So then 15, it gives you 18, 20 is at 28, and 25 is at 42. And we end up with a line that looks as follows. So that links to here, to here, to here, to here, to here. Obviously your graph might look slightly different because this is not properly scaled, but we don't need a perfect graph for this question. But what we're then going to look at is we want to find the area of the graph, and as it's an estimate, we can't use integration in this step because we don't have an equation of the curve, but we can use the trapezium rule to find the area under our graph. So here, if we use the trapezium rule, so the trapezium rule is h over 2, and then it's going to be y0 plus y, in this case, 0, 1, 2, 3, 4, 5, plus y5, plus 2 times y1 plus y2 plus y3 plus y4. To find h, it's going to be b minus a over n, but essentially in this case is b 25 minus 0 divided by the number of strips, which is 1, 2, 3, 4, 5. So we've got 5 strips, so h is 5. So therefore we plug in our numbers, so it's going to be 5 divided by 2, and then we've got y0, so y0 is our first y value, which is 2, and y5 is our last y value, which is 42, and then plus 2 times the rest of the y value, so it'd be 5 plus 10 plus 18 plus 28. And then from here we can just plug that straight into our calculator. So 2.5 times 2 plus 42 plus 2 times 5 plus 10 plus 18 plus 28. Plugging all that in, we get a distance of 415 meters. So this is our estimate for our under the curve, so the distance that it travels, so the runway estimate. Then part B says explain whether your answer to part A is an underestimate or overestimate of the runway length used to take the jet off. So it says that the jet accelerates smoothly. If it accelerates smoothly, the change will look more like a curve than it will do a straight line. So here we find that our area is actually going, our distance estimate is going to be an overestimate. Our distance is an overestimate because we have this bit here, which is not taken into account, which is when we do, if we had an acceleration of a smooth one. So here this is an overestimate of the distance, as the actual curve will be below our estimated curve, and therefore the area will be reduced. And that will be it for this question. If you have any further questions, please let me know.